Hello guys, in this video we will be talking about how a cascade system works. As you can see here, we have a simple diagram provided by theengineeringmindset.com. Theengineeringmindset.com is a really good site for learning basic engineering and how these principles work. They have a lot of videos on how the expansion valve works and how these compressors and condensers work. Be sure to check those out as well. Anyways, back to what I'm saying. So, if you first look at the cascade system, it may look like you might not understand everything at first. But if you've watched my other video on how a refrigerator works, this is actually fairly simple. If you look carefully, you can see that the cascade system is actually separated into two parts, indicated by the blue line that just appeared on the screen. If you look at this, you may recall that these are just two separate refrigeration systems acting into one. But there are some changes from the previous video. So, if you look here, instead of having it in a capillary tube, we now have this expansion valve here. This expansion valve has a bunch of components inside it. If you want to see how it works, check out one of the engineeringmindset.com videos, and it'll explain how the capillary tube is fitted inside of this expansion valve. This expansion valve is more efficient because it allows more of the liquid to be cooled, and it also has sensing and solenoid valves in it, which causes it to be more efficient and more helpful. Now, you may notice this new part in here called the liquid separator. I like to call this the central area because it is kind of the central area for everything. So here's where most of the refrigerant is being stored when it's not being used. So as you can see, both the evaporators and the condensers dispense into the central area. And the central area has two exits. One is when the gas rises, and the other is for the liquid that falls down. After, the gas that exits from the compressor and the condenser is a liquid, so most of it will just go into the lower part. However, when this liquid goes down, it'll come into this pump. This can also help control whether the liquid goes in or not. This can be fitted with a leak detector for better uses. Afterwards, it's fitted into a regulating valve which helps the liquid flow better. And then it's passed through the evaporator, and then as we see before, it's a liquid and vapor mix. And now it is sent back into the central line. Because it's a liquid and vapor mix, some of the vapor will rise up here, the liquid will repeat the cycle again. Now let's follow the vapor line. The vapor line goes up to here. It's a low pressure vapor. It goes inside of this compressor, and as before, we've learned that compressing it turns it into a high pressure vapor. It then comes to this new feature, also known as a cascade condenser. We will talk about this feature later though. Let's assume this just to be a normal condenser. Afterwards, it is then sent down into the receiver, which is basically just a place for storing all the liquid. As you can see, you can also see this dark red line that comes directly into the receiver. Only possible liquid that's in this pipe will fall directly into the receiver because we don't want to ruin the gas that goes into the condenser. Now this pure liquid is coming down and goes into the expansion valve and repeats the cycle. As you can see on the other side, we have a similar thing. Except this time, this cascade condenser replaces the evaporator, not the condenser. Now let's talk about the cascade condenser. So, this cascade condenser is the part that connects the two systems together. On this side, it acts like a condenser. On the other side, it acts as an evaporator. Typically, on the left side, you'll want more hotter refrigerant, like ammonia or hydrocarbons. And on the right side, you'll want colder refrigerants, such as CO2. Because the liquid is colder here, it'll help condense the liquid over here better, making a better cooling effect. And because the liquid here is more hot, it'll evaporate the liquid here better as well. This whole cascade system results in a better transfer of heat, and it is also very efficient, which is why most modern refrigerators use the cascade system.